Hey guys, so it's the You Ought to Know section, and here we are on page 161, and we're looking at 3D shapes. So the 3D shapes that you'll see are the cube, the rectangle, and the cylinders on the next page. So a cube has all lengths the same, right? So the length of the cube and the width of the cube and the height of the cube are all going to be the same. We'll just call that S. Okay? A square has the same sides, like this and this. With a cube, the depth or the height is the same size as well. So the volume of the cube is just the side cubed. That's why it's called a cube. A square is the side squared. That's why it's called a square. The surface area is just 6 squares. Okay? So here's 1, 2, 3, and the ones you can't see on the bottom, on the back side, on the left side. So there are 6 of the exact same squares. That's the surface area. For a rectangular box, you're not necessarily going to have the same dimensions. A rectangular box is a rectangle with a height component. So we take a rectangle like, let's say, length times width would be the rectangle, and then we add a height to it. So this would be the rectangle on top. Let's say the top would be your two-dimensional rectangle, length times width. Let's put an L up here. So length times width, and then you add the height to it. The volume is just those 3, length times width times height. The surface area, you're going to have 3 pairs of sides. So you're going to have 2 sides that are length and width, like this one right here and one on the bottom. You're going to have 2 sides that are length and height. This one right here, call this a 2. This one right here, and then another one on the back side. And then width times height would be this one, right? So this one here, and then one on the left. So you have 2 each of those to get the surface area. So as it says, add all 6 sides, but beware that those come in pairs. Let's talk about the cylinder. Still on page 161, but we're about to be on page 163 for question 15. Okay, so the cylinder is the circle times the height. That's going to be the area of a cylinder, right? So, it's going to be the shape of the cylinder is a circle with a height. The volume is the area of the circle plus the height. Okay, so you know how to get the area, right? So here's a radius. Here's a radius that's going to help us get the area, and here's the height. So simply get the area and multiply it times the height. And the surface area of a circle is interesting, of a cylinder is interesting. You do the area of the top and the bottom circles, and then you do the area of this part around, which is like a label on a soup can or a can of fruit or something like that. If you were to take this and lay it out flat, it would be a rectangle. It would actually be a rectangle. So look at number 15 here, and go ahead and pause it if you want a couple of moments to work on it. But we're going to work with this solid right cylinder right here. I'll just let you read this and we'll jump on it. So we're absolutely going to find the surface area, because quantity A is the surface area, quantity B is 60 pi meters squared. Well, to get the surface area, we want the area of the 2 circles plus the area of that rectangle. So the 2 circles, if the radius is 3 meters, so if this radius right here is 3 meters, that means the area of the circle is going to be 9 pi, right? It's going to be pi r squared. So the area of the circle is 9 pi. So that's this circle and that's this circle. So that's going to be 18 pi for the area of the 2 circles, 18 pi. And then the area of the rectangle. So that's going to be the height times the circumference. That's how we're going to get that. Well, the circumference is going to be all the way around, right? So if the radius is 3, that means the diameter is 6. And that means the circumference is 6 pi. So the circumference is 6 pi. The height, we're told, is 10. Height is 10. So we simply do 6 pi times 10, right? because we're looking for height times circumference. Circumference 6 pi, height of 10, that's 60 pi. So 18 pi plus 60 pi is 78 pi. Definitely 78 pi is bigger than 60 pi, and this is of course meters squared. 78 pi is bigger than 60 pi. The answer is quantity A. Okay? Number 16, now we're going to be talking on page 165 about a cube. So they give you the volume of the cube, and they want to know the longest possible straight line distance between two corners of that cube. So again, pause that if you want some time to look at that. I'm just going to launch right into the explanation. That longest possible distance is actually going to be the distance from here to there. Now, I don't know if you can visualize it, but this is the upper left-hand corner, upper left back corner. And then we go to the lower front right corner. So we're going across the cube. Okay, imagine, a Rubik's Cube or something, anything that's cube shaped. Here we have some lens wipes. Here we go, some nice and clean. So we're going to go from here to here. So we're going to go from the back left to the front right. And you can see that that is the greatest distance you can do. Back left to front right. That's going to be the longest distance in there. What we have to do here is two Pythagorean theorems. So the first thing we're going to do is we're going to get ourselves over here. So we're going to get from the back left to the front right. But we're going to stay on the top. Well, that's going to be a hypotenuse. This is a side right here, and this is a side right here. So this is going to be a 45, 45, 90. And that's going to mean x, x, and x root 2. So we need to figure out what the side is. We need to figure out the side of this cube. Well, the volume is 125 centimeters squared, and we know that the volume of a cube is equal to the side cubed. Well, the side cubed is equal to 125. That means the side is equal to 5. The side is 5, the volume is 125. So if the side of this thing is 5, right, then that's going to be a 5 right here. That means 5 root 2. So this distance right here is 5 root 2. That gets us to the top right, but we're not there yet. The answer is not going to be A because we're not there yet. We still need to get to the bottom on this, okay? So when you think about it, what you've got now is this blue line is going to be the hypotenuse of another triangle, and that other triangle is going to look like this. Here's one side, there's the hypotenuse. So that 5 root 2 that we just figured out is one side, call that the base of the triangle. And then this height of the cube is going to be the other side, call that the height of the triangle, and then the hypotenuse is here. So this is also going to be 5 because it's just the height of the cube. So we have a side of 5 root 2, and we're looking for the hypotenuse. So we're going to do 5 squared plus 5 root 2 squared equals, let's just call that d squared for the distance. 5 squared plus 5 root 2 squared is going to be d squared, right? Because that's the Pythagorean theorem. So we've got 25 plus 50. You square the 25, you also square the square root of 2. So it's 25 times 2, that's 50. 25 plus 50 equals that distance squared. 75 equals d squared. 75 is 5 root 3. When you take the square root of 75, you get 25 times 3. 25 is a perfect square, so 5 root 3. So the biggest distance we can do is 5 root 3, and that's going to be answer choice B. So that's our three-dimensional shapes, and on the next recording, we'll do the third side rule and some more geometry.